Alright, let's look at an example application now that we've got a way to find all the angles and all the distances in a triangle. We've got an application where we'll create a triangle and use it to, in this case, a surveyor is going to determine the height of a peak of a mountain. So all they have to do is, if you've ever seen the surveyors with their equipment out there, if he gets an angle from the base here, he gets an angle from the top of this device and determines it to be 35 degrees, and then goes a distance of 900 meters, and he finds another angle of elevation. This time it's 47 degrees to that same point on the peak, and that sets up a scenario for us to use the law of sines. Now let's talk about what we know. We can determine the C angle from the 47 degrees because this is 180 degrees, so if I just take that 180 minus the 47, we're going to get 133. Okay, and so let's go ahead and pop in here. The C is 133. Now this also gives us the measure for A, because A is just going to be 180 minus the 133 minus the 35. Okay, so for that measure, we're going to get 12 degrees. So let's mark up A, 12 degrees. Let's go ahead and use the law of sines, and now we can say that the sine of the measure for A of 12 degrees over the opposite distance, 900 meters, is equivalent to, and in this case we want to find the length C, so sine of 133 degrees over the opposite side gives us the length for C. So we have C is equal to 900 times the sine 133 degrees divided by a sine of 12 degrees. Okay, so that's going to be roughly equal to 3,165.86 meters. Okay, so if I want to put all the units in, of course this is meters, these are degrees. Okay, so we have a length for C. Alright, and so that's really all we're going to need from the law of sines if we think back to solving a right triangle, because I now know C is 3165.86 meters. And so if we think about solving right triangles, we know the sine of an angle is the opposite over the hypotenuse, right? SOHCAHTOA. So the sine of 35 degrees is equal to the opposite, which we can call B, over the hypotenuse, which we've determined to be 3165.86. Alright, so to find B, all we have to do is multiply both sides by the denominator here, so we're going to get a B is equal to the product of 3165.86 and the sine of 35 degrees. Okay, and drop that in the calculator, and B is going to be roughly 3165.86 times sine of 35 degrees equals 1,815.86. And that's meters. Alright, so the only thing we have to do now is account for the height of the device here, because our little triangle that we pulled out of there was from the base of the top of his device there. So we'll just add those 2 meters to this, and we'll come up with the height of the mountain. So the mountain height is 1,817.86 meters.